Welcome to PFAS Solution Spotlight, a new podcast series from Aqua-Aerobic Systems featuring the AquaPRS PFAS removal system. In this first episode, John Dyson, product manager, will introduce AquaPRS technology and what makes this solution different from others on the market today.
Welcome to this episode titled, What is AquaPRS and why is it different? Today, we're going to start off with discussing the traditional PFAS removal solutions, which are granular activated carbon, ion exchange, and RO systems. All of these technologies are well-known technologies, have been around. They all have limitations to exhaustion of the granular activated carbon at low absorption rates, ion exchange, other contaminants that may cause issues, RO, the waste stream. The new AquaPRS technology, which we're going to discuss, addresses many of those items as a technology. So how does the AquaPRS technology work? Well, it's a very simple process. It really can be broken down into 3 steps. First, we have our absorption contact tank, where we take stock absorbent, we add it in a concentration from 5 grams to 40 grams per liter, where the contact will occur. This is generally 5 to 10 minutes, depending on the application. As influent water comes in contact with the slurry. That slurry is transferred to our ceramic separation process that produces a microfiltered effluent quality, while the absorbent is recirculated back to the absorption tank. So we can continuously load up the PFAS onto the absorbent media to maximize the usage of the absorbent media and reduce the amount needed to remove PFAS over an extended period of time. The process continues. Periodic back pulses occur during that time frame, but there's no waste. Ultimately, when the absorbent material is exhausted with loading of PFAS, we then have to remove that absorbent material, and it's a completely automated process while pausing the influent flow to the system. We remove the absorbent from the contact tank and the separation system, and we put that into a settling tank. That settling tank allows the absorbent to settle for 24 to 48 hours. The supernate is returned when the system is put back online. So the removal of the system and the reloading of the system takes about an hour. So it's a completely automated process and it's simplified. The concentrated material is generally in a concentration of 20 to 25% concentration, so we've minimized the amount of water. So it's basically broken down into 3 steps: absorption, separation, and waste minimization is the basic process. So ultimately, you have the initial fill, you have the running of the system, which may be 2 weeks to many months, up to 6, 7, 8 months before that absorbent has to be replaced. Then ultimately that change out occurs within the process. So very simple, no waste during the time frame. Only waste from the system is related to change out in the process. So why does it matter? What's unique about the AquaPRS process is we use absorption and we use separation. But our absorbent is 1 to 3 microns, so it's very small. It's many folds smaller than granular activated carbon, ion exchange, even packed material. So when you really think about the surface area that's there of a normal granular activated carbon media versus the very small size, we've dramatically increased the physical surface area, allowing for high absorption of PFAS at high concentration along with kinetic rates. Here's the absorbent at about 10 grams per liter. So it's really waters coming in contact with a slurry, ensuring removal of PFAS. So why does it matter? That microabsorbent, shortens diffusion pathways, makes the rapid absorption occur very quickly, less than a minute. You reach equilibrium very quickly, and you get other advantages in terms of removal of other contaminants. In terms of residuals, what we're finding generally is we're going to be 10 to 15% of the volume of, say, granular activated carbon, and in some cases even less than that material. How do you dispose of that absorbent material? Well, you can put it into a landfill, the proper landfill, thermal destruction processes, or deep well injecting. So it's very easily handled and is in small volumes. Because we have our ceramic separator process that has a cutoff of 0.1 microns, along with that, we were able to remove pathogens, turbidity, all of those type of things from the water while producing a drinking water quality out. So we can handle, variable water conditions and provide effective disinfection or pre-treated water for disinfection. What's important to realize and how the AquaPRS system is different. It's an active process versus GAC or ion exchange, which are typical solutions that most people think about. We get much more rapid absorption rates. We have that ceramic barrier, okay? We get very high performance on difficult applications. We minimize the amount of waste, and it's very automated versus some of the other technologies that like GAC and ion exchange. We're at the end of our first podcast on the AquaPRS process. The next podcast will be titled, Does It Work in the Real World? It is a case study of a North Georgia installation for drinking water going from pilot stage to full-scale operating installation. Thanks for watching this podcast today. If you have questions, my email address is here. Look forward to your questions in the future. Thank you.